Well, I feel particularly honored and a bit worried because I'm following Venkat and I'm preceding my good friend Simon Ritter. So gosh, I just hope to keep you alive and engaged and awake here because I'm kind of a quiet, subdued person actually. Anyway, so hey, thanks for coming to this afternoon session on Full Stack Reactive Kotlin. Yeah, actually, that's a little bit, I feel guilty not putting that in there. I also feel guilty putting that in there because what I would like to do is kind of showcase the Kotlin stuff because I think I'm always looking for better ways to show exactly what I want to show and not get other stuff kind of cluttering it in the way. And I feel like Kotlin gives me the best path forward to do that. However, I also will show you some Java code. Well, we'll write it together. How about that at the end? Because I need to create a service and a client, and it just seems fair to kind of divide the work, right? So you get a little taste of both, but I am going to focus in on the Kotlin side of things, and I'll explain why as we get into it. My name, by the way, for those who don't know me, is Mark Heckler. The best way to reach me, I'm told we only have like 2 hours here today. Is that right? Okay, so a little less, maybe a little less, about 50 minutes. So I'm going to do my best to hit that mark and get out of Simon's way so he can come up. But to give you the full value in that 50 minutes. So I'll try to move quickly, but not so quickly that I just fire hose it, right? Because I think it's important that we all walk away with better understanding. So that is the goal. If you have any questions or comments or feedback, if we have time at the end, I'm happy to take them. However, if we run out of time or if you think of something 10 minutes after the fact, always happens to me, but if you think of something later or even 2 days later or whatever, you can reach me online. The best way, the level best way to reach me is Twitter. Most of your favorite open source frameworks, the committers to them are best reached on Twitter. So if you're not on Twitter, that's the place to go. If you follow me on Twitter, you probably know, well, about almost as much about me as my wife does. If you don't follow me on Twitter, why? Why do you not follow me on Twitter? But it's MKHeck. Reach out to me. If you have any questions, comments, or feedback, and they don't fit in 280 characters, or you just don't want to share them with the public, the whole world in general, my direct messages are open. So just DM me. I'm happy to carry on conversations, at length. If you're not on Twitter, or if you just have a lot of stuff you need to say, questions, comments, feedback, anything else, send me an email. I don't check that quite as often as Twitter. I kind of live on Twitter. I even sleep tweet. Has been known to happen. But I do check email from time to time, so that's a good second choice. So who am I? I've authored several blogs and blog posts. I've co-authored a couple of books. I've contributed content and code to several other books, a few of which actually even recognize my contributions. That's always nice, right? With regard to the others, well, I wasn't planning on living on the royalties anyway, so it's okay. I am a Java champion and a Java 1 Rockstar and a Groundbreaker ambassador and a few other titles, honors, and awards that combined with a few euros can get you a good latte. But, it's nice. I am a professional problem solver. That's not my official title, but it's what I do. It's what you do, right? It's what we all do. But my official capacity is as a Spring developer and advocate for Pivotal. I am also, in kind of an extra passion project, the creator and sole curator of the Spring Noticias en Español site. So if you're a Hispanohablante, if you speak Spanish and you have Spring or Java or Kotlin articles or videos or resources of any kind you want to share, please do reach out to me. I'm happy to help amplify your voice and share with the community. So with that, let's talk reactive programming. Sometimes folks, there's actually quite a bit of confusion about what reactive programming really is. So I like to kind of start out and set the foundation, right? So we're all kind of on the same page. I love this quote by Rossen Stoyanchev. He's one of our Project Reactor team members at Pivotal. He says, in a nutshell, reactive programming is about non-blocking, event-driven applications that scale with a small number of threads, with backpressure as a key ingredient that aims to ensure producers do not overwhelm consumers. Now that packs a lot of meaning in one sentence, which is why I like it. But let's unpack it a little bit, shall we? For starters, let's talk about the typical way of scaling applications that Java has employed for a good number of years now. Typically what happens when you need to scale, for each additional connection, is an additional thread. An additional thread is created. And over time, of course, you wind up with a lot of threads doing what? Nothing. They're blocking, right? So they're waiting for a response from a database or a file system or another service, right? So we have a very linear scaling going on. It's very easy to reason about, right? With each additional connection, we get an additional thread. But at some point, we hit that n number of threads and we max out our threads. And at that point, the performance kind of does this hockey stick, right? So our scalability effectively stops and our performance essentially spikes because at some point, someone has to wait. So it's probably, it's easier to reason about, but it's not the most efficient. What we were looking at is a way to scale with a small number of threads. Now, our friends in another environment found that you can do amazing things scaling with a single thread. The problem, of course, is that with a single thread, if anything goes wrong, everything stops, which is kind of a problem. So what we wanted to do is manage a small number of threads and maximize utilization of that. So a fewer number of resources, but a much larger amount of utilization, right? What this allows us to do is separate off, let's say, blocking requests, if we do still have to deal with services that block, and keep those independent to maximize, again, that throughput, that scalability. We also wanted to incorporate backpressure. Now, sometimes when people hear reactive programming, what they think in their minds is asynchronous programming. Has anyone done async programming? Yeah, a few hands, right? It's a lot of fun, right? Yeah, fun in that kind of very painful, I can't believe I'm doing this way. You've probably heard of the term callback hell. I'm convinced that that was coined by an optimist. Right? I think it's actually worse than that in many cases because the typical way you write asynchronous code is with callbacks. You have these you have these nested callbacks in which you say when this is complete, do this, and when that is complete, do this other thing, and when that is complete, do this other thing entirely. It gets rather messy, so readability suffers, and it also lacks backpressure. Why is backpressure so important? Because in many cases, we have a producer that produces values that it's pushing out to whoever is listening, right? And let's say it's producing and pushing 1,000 values per second. And let's say you also have a slower subscriber, a slower consumer of those values that can maybe process 10 per second. What happens? Well, in an asynchronous only world, typically what happens is that client is overwhelmed, right? It just falls over. With backpressure, what this allows us to do is for a slower consumer to say, look, I can only handle 10 at a time, or 50 or 100 or whatever that number may be. And once I'm done processing those, I'll let you know. I'll request the next 10 or 50 or 100. And that allows you to shift the conversation, to shift the control. It doesn't change the fact that you have a very fast producer producing a crazy number of values and a very slow consumer consuming a much smaller number. But what it does is puts control back in your service, in your cloud environment where you can control that versus on someone's iPhone 3 countries away, which you can't control. So it puts more control back in your hands. So let's see. So all this is kind of based around reactive streams. Now, where does reactive streams come in? Well, some very intelligent folks across the industry said, look, most of these issues are in the interactions, right? Between the services, and again, a database or a file system or what have you. If we could do something about those interactions, I think we can kind of crack this. So the reactive streams specification came into being. And this was a good cooperative effort because what often happens in our industry is that everyone solves the problem in independent ways that are incompatible. Never seen that, right? And of course, when that happens, who gets caught in the middle? We do. We're the ones having to kind of write the code that brings all this stuff together, right? So, some good folks got together from Kazing and Lightbend and Twitter and Netflix and Red Hat and, of course, Pivotal. So we got together and said, look, we could solve this in incompatible ways, but it doesn't make a lot of sense. Let's agree on a foundation. And thus the Reactive Streams initiative was born. The Reactive Streams initiative consists of 4 things. The specification, of course, the textual spec. The API, which as you can see is very simple. This is it. This is the whole thing, and I'll get into that in a second. You also have examples of how to use that or how to implement that API as defined. And then also, arguably, the most important part is the TCK, the Technology Compatibility Kit. So that if you do create an implementation, you can determine how compatible that implementation is and where it falls short, so you can fix that, right? So getting back to the API itself, there are 4 interfaces. 4, that's it. It's very simple, it's very granular. Which means that you have to do one or two things. You have to either create your own implementation or leverage one. And I would suggest that we have some very good implementations out there already, well-tested, proven, performant. You should probably start there, and especially with Project Reactor, which we'll be talking about today. A quick summary, though. You have 4 interfaces. One is the publisher. That's the thing that produces values, right? Then you have a subscriber, which is the thing that consumes those values. A subscription is the contract entered into between a subscriber and a publisher. And then you might have a processor, which actually incorporates both the subscriber and the publisher so that it can receive values, process them in some way, manipulate them, and then pass them on to its subscribers. So again, very simple, very granular, and everybody has a little different take on this, but they all, again, are demonstrably interoperable. Now, actually, I'm going to back this up because I don't want to get everybody excited about the burning tire yet. But to explain a little bit, because again, this is pretty high level, or low level, however you want to consider it. In typical imperative Java, we typically kind of separate things into a couple different concerns. So for instance, when you have a method that returns something, you might return an object of type T. Or if you need multiple things, you might return an iterable of type T, a collection of some sort, right? We felt within Project Reactor that it kind of made sense to do the same thing and to specialize the publisher interface. So we have 2 different kinds of publishers. One is a mono, which is 0 or 1. You should expect at most 1 value. And the other is a flux, which is 0 to n values. And you'll have some operations that apply equally well to both, some that don't, right? Some that make sense when you're expecting a single value, some that make sense when you're expecting either a small collection of values or maybe an indeterminate number of values over an indefinite amount of time. So that's the mono and flux, which is kind of how the packaging and the name came about, because in Project Reactor is independent of Spring. You can use it anywhere. You can use it on Android. I mean, that's not our target, but I know it's being done. It also is able to be used with any Java application, so it doesn't have to be Spring. But to consume it using Spring, we've baked it in as of Spring Framework 5 on up. And that's where Spring Web Flux came in, based on the name Flux, right? Our publisher, our multiple value publisher. So with Spring Framework 5 and September of 2017, there were 3 big stories. One is baselining on Java 8 instead of Java 6, so we get all the goodies, right? The streams, completable futures, lambdas, what have you. The next one was Kotlin, which if anybody came to my talk yesterday, did anyone come? Oh, good, you came back. That's great. Thanks so much for that. But Kotlin was a big story. Full first-class support for Kotlin. Which is why it's such a big deal. If you haven't used Kotlin, I was a bit reluctant because, with Java going to a 6-month release cycle, why bother, right? I mean, we'll get more stuff sooner. But Kotlin gives you some really nice, it kind of boosts your superpowers in terms of productivity, which is kind of what Spring does as well. So it seems like a very natural fit together. But the third thing is reactive capabilities based on WebFlux, which is based on Project Reactor. So anyway, I say all that to bring us to this point. So let's code. This is my seat, the hot seat. We're going to do everything live, and I can't see because of all the lights, so this ought to be really fun. But, who needs to see to code anyway? If anybody can just watch this and tell me what I'm typing, I'm sure it'll be fine. I'm kidding. I close my eyes when I code anyway. It's no big deal. Okay, so if those of you laugh knowingly, you know me. All right, so we're going to start here. This is the Spring Initializer. This is your starting point for Spring Boot-based microservices on the web. You don't have to go here, right? You can code them all by hand. You don't have to use any auto configuration or any helps whatsoever. However, that's like Superman walking to his next crisis, right? So you probably want to start somewhere where it gives you that boost to get started. This allows you to pick your dependencies, choose a few options, and it provides your project for you. You zip it up, download it, unzip it. It actually includes your dependencies, your main application class and main method, and that's it. So you're still writing the code, but it gets you that kind of leap off, kind of that springboard start. For starters today, and you have options even with the simple version, you can also go with more options and see a lot more stuff here, but I'm going to keep it very simple. Since we're going to be using Kotlin, I'm going to go full on hipster here, and we're going to go with Gradle. but do what makes you happy. I mean, you can use Kotlin with Maven, you can use Java with Gradle. I just feel like when I use Kotlin, I want to use Gradle because actually our Kotlin build scripts our Gradle build scripts now are using Kotlin when we write Kotlin code, which is kind of sweet as well. All right, I'm going to use version 2.1.5, which is the current version of Spring Boot. I'm going to just change this to the Hecklers because example.com is so 2018. And then we're going to create a coffee service. Now, this won't be the coffee service you saw yesterday if you came to my talk, because we need more coffee, right? That was yesterday's coffee. So we're going to start off and do some fun reactive coffees here. So I'm going to bring in the dependencies for Reactive Web, which gets a couple of things here. Reactive Web applications with Spring WebFlux and Netty. Of course, Spring WebFlux instead of Spring MVC. Similar capabilities. And this is another thing that I was going to mention and kind of skipped over. We didn't throw away Spring MVC because there are a lot of actual mission-critical applications running all around the globe using Spring MVC. It's a critical piece of infrastructure for a lot of folks, right? Critical piece of their tool chain. But what we did do is take on more work for ourselves. We created parallel packaging with parallel capabilities. It's more work for us, but I think it's just brilliant because as a developer, we're all tasked with learning so many new things every day. What if I could say that you could go full on reactive throughout your entire stack and your friction is almost zero? It would be so nice, right? And if you are using MVC and you're doing that 4.5 days out of every 5, and your boss comes to you on Friday at 1 o'clock and says, hey, we've got an issue with this WebFlux, this reactive application, can you take a look? Your context switching is almost zero. And I think that's just brilliant because the fewer things we have to worry about changing how we do things, we don't have to throw away 10 years of knowledge or 20 years of knowledge and how we've done something. We can leverage everything that we've got up to this point and still use it for everything new and get the full benefit of it. So I think that's kind of awesome. So anyway, parallel packaging, we've got Spring WebFlux instead of Spring MVC in this particular case for the reactive stack. If you're used to using Spring MVC, you know that the default engine, servlet engine, is Tomcat. But you also know that you can swap that out. You can use something like Jetty or Undertow. Same thing here with the reactive engine. We're using Netty, which is well established, tested, and proven. But you can also swap that out for any Servlet 3.1 compatible engine, so something like Tomcat 8 or Undertow or Jetty or what have you. But I like Netty. Netty is super performant and again, very well established. So we're going to stay with that. I'm going to bring in Reactive Mongo to use for a database connection and then an embedded Mongo because I just like it. And we're going to create our project here now. And I'll just drop this out on the desktop. And we'll open that up. Unzip. And we'll open that in our favorite IDE, NetBeans. Just kidding. Any NetBeans users out there? Oh, excellent. Okay, I like NetBeans. I like to joke, I like to kid them, but I've used NetBeans for years off and on. NetBeans is an awesome IDE, has great Spring support, no problems there whatsoever. It's just an awesome experience. Any Eclipse users? Eclipse is also an excellent, it is also an IDE. I've never developed a great fondness for Eclipse for some reason. That said, we do support it. We have a build of it called Spring Tool Suite. We have language servers and things that work with that and Visual Studio Code. I mean, it's got great cloud deployment capabilities to our clouds. It's that part I absolutely love. But for me, IntelliJ works a treat. IntelliJ is written by the same folks who lead and shepherd and drive development of Kotlin. So you might expect it's well integrated. So for me, IntelliJ it is. But use what makes you happy, right? Okay, so let me take this to distraction-free mode. And let's see if we've got everything that we need here. Is that large enough? Can everyone see that? Yes? We can take it a little bit bigger, I think. Font. Let's see. So I go to my font here, and I've got my high contrast embiggenist setting. Oh, that's nice. Okay, so yeah, so I've got that for some reason. There we go. Okay, we're going to start off here, and we're going to just create our application. and we'll walk through this as we go. So the first thing I'm going to do is create my domain. So in this case, I'm going to create a Kotlin data class. I will elaborate a bit on the Kotlin specifics. If you aren't that familiar and steeped in Kotlin, I think you'll have enough there to grab onto. If you have any questions, come see me later, or my other talk actually goes much more in depth on it, but I will kind of narrate this as I go. So we're creating a coffee. And of course, with Kotlin, you can create your primary constructor and your class header. And of course, you don't even need the constructor keyword. It's just right all there. I'm going to, I guess first I should start with @document because we're going to be storing our coffees in a Mongo data store. The data class gives us our capabilities of our on top of our getters and setters because of Kotlin properties. It also gives us things like our equals, hash code, toString, copy in functions, and what have you like that. So let's see, we'll annotate our ID field with @ID. And we'll make this a val, so it's like a Java final. You can assign it once, and ID of type string. And we will say, actually, it's a string, because it could be nullable, right? If in Kotlin, it's null safe. If you say something's a string, it's definitely a string. There's no way it can be null. Well, okay, there's always a way that anything can happen if you're sufficiently motivated in anything, right? But we'll assume in most cases it can't be, and we'll put the question mark on there so we can say it's okay for this to be null. Now, why would it be okay for an ID to be null? In this case, we know Mongo is going to assign that ID for us, so we don't want to require when we create a coffee that we pass in an ID. And we'll just assign a default value here of null. Again, Mongo will handle this for us. And then I'm also going to create a name field, and that will be a string here, and we'll assign a default value of any old Joe. So that's a terrible coffee, but you know, we'll go with that. I also, for this example, want to show, because many times this is a very simple domain, right? But if we're dealing with coffee, if we're creating a service for baristas to use around the world, we want to have operational insights, operational visibility. So we want to know what is being ordered when, right? So if we have a particularly popular coffee, we can order more coffees to keep in stock that are similar to that flavor profile. If that's not selling well, if we only sell one per year, we probably don't want to continue to stock that coffee. So we should keep track of coffee orders, right? Coffee orders. So we'll have a val coffee ID, and that's a string. And we'll also want to track when something was ordered. So we can kind of get an idea of, again, that frequency of order. And we'll make that an instant. Now, since we're dealing with the data store, we're going to be leveraging Spring Data. We're going to create an interface here called our coffee repository, and this will extend, in Kotlin to extend, you just have the colon, nice and clean and neat, and we will extend a repository interface defined in Spring Data, a reactive CRUD repository. So we can create, read, update, and delete. We're going to be storing objects of type coffee with IDs of type string, and that's sufficient. Spring Boot's autoconfig, by the way, sees that we've extended an interface in Spring Data, sees that we have a MongoDB reactive driver on our class path, and makes a connection for us. So it's very, very nice in that regard, so we can get down to business. So we have the capability to deal with our database, but we don't have any data in it yet. So what I'm going to do is just create a component, if I can spell, component, and we're going to call this our data loader component. And actually, for our data loader, what I want to do is inject via constructor injection. And again, our primary constructor is in our class header for Kotlin. I'm going to inject our coffee repository here. So coffee repository, there we go. Okay, so I want to create a post construct method so that at this point we can create some value. So I'm going to create a Kotlin function similar to a Java method, and we'll call this load. And in Kotlin, you don't have to do the whole method body here with the braces. If you have a single expression that evaluates, that provides your body, your function body. So we're just going to do a direct assignment here and just get started there. So the first thing I'm going to do is create a list of coffees. So let's see, does anyone have a favorite coffee? Oh, you were here yesterday. Okay. I can't argue with your taste, though. Just my spelling, C-I-N-O. Okay, there we go. Oh, and you too. Okay, that's cool. Actually, the double espresso is kind of becoming my go-to drink. What does that say about me? I don't know. Okay, I mean, were you here yesterday too? All right, well, this is good. I really appreciate you all coming back. Anyone else? Okay, I got 2 of them over here. Macchiato. All right, another repeat offender. Macchiato. Okay, and what was the other one? Corretto? Corretto. There we go. You from Amazon? Okay, all right. What? That is not a coffee. Okay, so, all right, but since it is Simon, I'm just going to add it in. So Azul. Okay, so we have our list of coffees, and then I'm just going to flux that. And that's a very nice Kotlin function that allows us to convert a list directly to a flux. We're then going to map each of those coffee names, which we can do this, right? We can do it the hard way, name coffee. There's no new keyword, but we'll just say name equals name, right? But in Kotlin, if you have a single parameter lambda, it's it by default. And then, of course, since it is the default, we can just do that, which is kind of nice, right? Again, it lets me focus on what I want to focus on, the functionality. And then we're going to flat map that, and we'll just do a repo.save save of it. Come on, IntelliJ, you're getting in my way here. And then, of course, just like streams, we have to provide a terminal operation. We have to subscribe to this flux, this publisher, in order to get it to do anything. Why is that important? Because publishers could do a lot of work, and if no one's listening, you're just wasting resources, right? So that's what's called a cold publisher. Now, there are hot publishers, and we can talk about that later if we have time. If not, please do ping me afterward. There are some exceptions to that, but generally speaking, publishers are cold because you don't want them, again, consuming a ton of resources if no one's listening. So we're going to then, just to wrap it up, we'll do a subscribe, and I'm going to just print line it, and that's good enough. Now, that works, but there are a couple things we can improve on, because as it shows now, what happens is each value, we create a coffee from that name, and then we save it, and then we show it. But how do we know that's all we have in our data store? Really, we should do a couple of things, right? What we should do is chain this flux coming out and do a then many. There are other ways you can do this, but this is a particularly effective way because it takes a flux and then it starts the new flux when the last one has completed. So if we do a then many and do a repo find all, what happens is all of those, once of course the subscribe happens, all of those values, all of those coffees are persisted, and then we just do a find all and show those. So we can verify 100% these are all the coffees we have in our data store. Now, the problem with that is that we've not done any cleanup, right? So each time this application restarts, it's going to try to save these same values. And even though this is Mongo, actually, some of them might stick, right? Okay. I probably just ticked off Mongo, folks. I'd like to dish on Mongo like I'd like to dish on NetBeans, but I do love Mongo. So Mongo is an awesome data store, unless you don't like it. But, you know, there are others. So what I'm going to do now, though, is before we kick this whole thing off, what I'm going to do is just a little bit of cleanup. So I'm going to do a repo dot, actually, we'll just do a delete all, right? And we'll delete everything there. And then once again, we can't do it like we would do it in imperative coding. We can't do a delete all and then start adding them because we don't know it will be finished, the delete, before we start adding values in. So just like we did with our find all below, we need some way to wait for completion. Once the signal of completion is provided, then we continue on. So we'll do once again, a then many, and we need a flux. We happen to have a flux right here, or a publisher, I should say. We happen to have one right here. So we'll just do that. Not bad, huh? Okay, so we have it. Let's go ahead and start this and make sure that it all works, of course, and then we'll charge forward. Oh, well, there is a small problem. I did forget to do this. This is on me. So we'll go to our build.gradle file. Oh, you know what? I don't have to do this, but I like to use the current version, the absolute latest, greatest version of Kotlin. So I'm going to just change that out because I do have wired connectivity now. So I'm not too worried about the performance. But I'm also going to change our embedded Mongo from just being available for testing to being available. So I'm going to, let's see, take this out of, there we go. We'll just do a complete rebuild or re-import. And it's telling us, hey, we may have some issues with our Kotlin code. Do we want to run the migrations, make sure it all works? And of course, no suspicious code found. We don't write bad code, right? I just make it a point never to bug my code so I don't have to debug it. That's a pro tip. Okay, so we're back here. Let's go ahead and restart this and see if we have any better results this time. Now, I will say this. If you're using Kotlin, the startup is just a skosh more slower than it is with Java. But I find the productivity boosts are such that I really don't care whether it starts in 800 milliseconds or whether it starts in 1.2 seconds. But, you know, again, your mileage may vary. So here we have our coffees, and they're all being persisted, and they're being persisted reactively, and everything seems to be working. We don't have any extras. We're not missing any, so that's a good start. So let me take this back to distraction-free mode. And we'll go on. So we've got everything established structure-wise, and we've got our sample data. Now let's build our internal API. So I'm going to create a service, and we'll call this, cleverly enough, our coffee service, and we'll build our internal API around that. Now, again, I'm going to inject private val, our repo here, so we can use that within our API. Kind of makes sense. All right, so what kind of abilities will we need to provide in our API? Well, we'll want to be able to get all coffees, right? Kind of makes sense. And we will do a repo.findAll. Simple, super simple. We also want to be able to get a coffee by its ID, likely. And we will pass an ID of type string equals repo.findById. And that also is pretty simple. Now, that kind of covers the basics in terms of our coffees, but what about that operational insight? What about the visibility we need so we can see what coffees are being ordered when? So that is where things get a little bit more complicated with our examples here, because if we want to get orders for coffee by ID. I love short method names, or function names in this case. What we expect is to provide a coffee ID, right, of type string, and to be able to get something back. But our repo is for coffees, not for coffee orders. And if we had an actual live application that's rolled out worldwide and we're getting these orders, we'd probably have these in an in-memory data grid, and we'd have access to this, and we could show at this second, these 5 coffees are being ordered, and 7,000 of this, and 4,000 of this. But we don't. We don't have this live yet. I'm still in that kind of minimum viable product creation stage. So appreciate you being early investors with me. But we're going to just kind of simulate that for the time being so we can fake it till we make it, if you will. So I'm going to create an interval. Flux.interval is a method that allows us to create a pulse, right? And I'm going to create just a pulse every, well, we won't do hours, right? That might be a little extreme. So every second, we'll just create a pulse. Let's see. So here we go. And then every second when that pulse occurs, what we're going to do is we're going to map to a new coffee order, right? And we'll use the coffee ID that's provided, and we'll just timestamp that with instant.now. Now that is okay. And since we're writing the code now, and we know we're going to be producing 1 coffee order every second, we probably don't have to worry about overwhelming slower consumers. However, I do try in my code to always do kind of that lean toward that best practice or that recommended practice, right? And when I do cut corners, I usually try to tell you in advance. If I don't, please let me know. It's a bad on me, and I'll straighten it out. But generally, I like to show kind of the optimal path forward. And generally speaking, you should never create a flux without defining what happens on backpressure. So if this thing gets going so fast and you have a slow subscriber, if you're not leveraging backpressure, you're kind of missing a key element of reactive programming. So I'm going to say that on backpressure, just drop the intervening values. Now, if you have something that where you can define averages, or if you say, hey, look, I want to create a buffer and buffer X number of values before I just pass them out the other end or whatever, that's fine. You can do all of that. But in our case, we're kind of looking at a live dashboard, right? We don't really care what happened 3 seconds ago or 3 minutes ago or 3 days ago. We care about the now. So in that regard, a way to just drop the intervening values is perfectly fine. So that's what we'll go with and keep it simple again today. This should work. I mean, doesn't this look like it should work? If only there was some way to test code. If only there was some way to test it before you just threw it into production. I mean, there is the scream test, right? You just throw it in production and wait for the screams of anguish. And then you ask what the problem is, where does it hurt, and you try to fix that. Probably not the most efficient way of doing it. So let's actually improve our efficiency just a tad. We'll go and create a new test. I'm not going to use our Killian here. Let's see. So come on, there we go. We'll use JUnit 4 for the time being. JUnit 5 is coming up fast. It's got some support. I just going to, again, keep this very elemental today. And we will create our internal API tests. And I'm going to create a setup method, and then let's create tests for each of those. Now, the first thing I need to do is indicate that we're going to be running this with Spring Runner, which gets us our Spring testing niceties. And we can load our entire context, our entire application context with Spring Boot test. I'm actually going to focus in on our WebFlux capabilities because, again, we're just testing our internal API. There's no reason necessarily to spin up our entire app context. And we're going to be, we'll need actually our coffee service so we can use that. I'm also going to auto-wire that in. I'll inject that coffee service so we can leverage that. I'm going to assign that to a latent var, so again, it can be auto-wired in. And we'll call this service, coffee service. There we go. I'm also going to create a mock bean for our repository. Once again, latent var, and this will be our repo, so we can define what we expect to happen in terms of a limited data set. We don't have to spin up our data store and all that. Now let's create some coffees. I just need a couple of test values, so private val coffee1 equals coffee, and we'll create an ID 000, oops, let's do zeros, dash test dash 111, and we'll create a test coffee name. Is anyone familiar with the brand Taster's Choice? It's a truly terrible freeze-dried instant brand in the United States. If you ever get a chance to try it, just don't. Save yourselves. But I like bad puns. I'm the master of bad jokes, okay? So if you didn't know that, apologies. But we're going to create a coffee named Taster's Choice. Wow, tough crowd. Okay, so we're going to also, because we need another bad coffee, we're going to create coffee 2. We'll change our ID here. Has anyone heard of Folgers? Another truly terrible coffee that I hope you never have the misfortune of testing. But we're going to create a suitable rival to that. We're going to call it Failgers. And I think that's somehow fitting. And then let's just create, let's just define what happens. So in this case, we want to do a Mockito dot when. And when we do a repo.find all, we should then return, right? Flux.just coffee 1 and coffee 2, right? That's pretty simple. Okay, now we also need to define what happens when we ask for 1. So Mockito.when, when repo.find by ID, and we find on coffee 1's ID, then we want to return a mono of just coffee 1, right? Coffee 1. And we'll do the same thing with coffee 2. When we search on coffee 2, first, there we go. Coffee 2. We should get back coffee 2. Now, if you have sharp eyes, you've probably seen that we've got a couple of red lines here. And it's because it's saying there's a type mismatch. It requires a string. But what we actually have is a string. We have a nullable string value. And that's because if we go back to our app, when we defined our ID, we see that it's nullable. So Kotlin, out of an abundance of caution, is saying, hey, I'm not 100% sure that this is not a null value. So you can do a couple things. What I like to do is the most direct approach. There's an operator in Kotlin called the non-null assertion operator. A friend of mine, good friend of mine from Chicago, Illinois, named Todd Ginsburg, actually coined this term, and I've loved it, so I've used it ever since. He refers to it affectionately as the hold my beer operator. Because what it does is it turns off Kotlin's null checking here. We just do a bang, bang, and Kotlin, the problem just goes away. Now, please, this is one of those bad examples I'm going to show you, okay? So this is not the best practice. Please don't litter your production code with the hold my beer operator. Please don't do that. However, for tests, and since we can see right here, we have an ID assigned, we know that it's okay to do this. So I'm going to do this twice so we can proceed. So we've got our find all defined. What happens when we do a find all? We've got our find by ID defined. And let's get down here for our test. So I'm going to change this up because this is another neat thing that you can do with Kotlin testing here. So we're going to change this from get orders for coffee to get orders for coffee. Look at that, by ID. Yeah, you really can use emojis in test names. Yeah, it's awesome. And I know what you're thinking. You're probably like, you're not going to be able to concentrate on the rest of this whole presentation because you're just going to be thinking about going in next week and rewriting your tests in Kotlin just so you can put those emojis in. You're welcome. Okay, so the next thing I'm going to show you is how you get around some very difficult things in testing, because in an imperative world, when you test, it's fairly, at least conceptually simple, right? You issue a request, you get a response, you compare what you expected to get with what you got, and if they match, you win. If they don't match, you have a problem that needs fixed. And it's largely the same with reactive testing, except with a publisher, you may have a sporadic publisher, which means that you might get a value for every second for 3 seconds, and then you might get your next value in an hour. And that's hard to test, right? Unit tests take a long time that way. So there should be some way to compress time, or as I like to call it, time travel. That's why I wore my Doctor Who shirt today. I always try to dress appropriately. So we're going to do a little time traveling here, and this is part of Reactor test, right? So we can use the step verifier with virtual time. And this, again, allows us to time travel and kind of compress time a little bit so we can get on with things. So I'm going to use my service, and we'll do a get all coffees, right? And let's see, then we'll, actually this, since we're doing our get orders first, let's start off with that. Sorry, I kind of bounced around in my test case brain there. So get orders for coffee by ID. We'll use coffee1, let's say, ID, and we'll take a few values. This is an example of Backpressure. We're going to take 10 values. That's it. Don't give me any more. As a publisher, just give me 10. You know, I'm a subscriber, just give me 10. When I'm ready for more, I'll tell you. If I'm never ready for more, I'll tell you that too. So then, once we have requested 10 values, we'll then await, right? And we can await a certain amount of time. So what I'm going to do is, obviously we wrote the code. We know that we're going to get 10 values in roughly 10 seconds normally, right? But out of an abundance of caution, we're going to wait an hour or 10 hours. Who cares, right? We're time travelers. It doesn't matter. And then we're going to expect next, and we should get our coffee. Actually, you know what? Because in this case, we're asking for 10 values. So we should expect 10 values, right? And then we will verify complete. So let's run that, and we'll see if that works. And wow, where's the time going? I may have to kind of leave some of this for you to go back and check in the repo just so we can get through the other stuff. So again, it's telling me that I need to do the hold my beer operator. So we'll go ahead and proceed now. And we should get a green bar, right? And we all know what a green bar means, except something is wrong here. I love that when that happens. Huh. Well, that never happens. So oh, there it went. Well, I wonder why that took so long. That's interesting. Let's try that again. If it just hangs, we'll know that there was just something, there's something terribly wrong here. Yeah, it's just in the startup. That's so weird. Okay, well, I mean, it's a, but it's not the test. Obviously, it didn't take 10 hours. So we have a green bar. Our test passed, which means one of two things. Our code works or our test doesn't. So we actually need to verify which one it is. So I'm going to expect 11. We're still asking for 10. We're expecting 11. So this should fail. Root for failure. Okay, so it failed. So that's actually what should happen in the amount of time. So we'll go ahead and change this back and make sure this works, and then we'll move on. Okay, so test passed. Perfect. All right. So again, I leave the other ones. They're straight pass-throughs, so we shouldn't really have to worry about those for 100% coverage. Please do feel free to add them in or just check out the code. So let's go back to our main application class, or our main file here, and let's go ahead and build out our external API. So at this point, we want to probably create a REST controller, and we'll create our base mapping of coffees, and we'll create our coffee controller, and once again, private val. In this case, we're going to inject our service, right? We're going to leverage our internal API to build out our external API. So what do we need? Well, we'll want to be able to get all those coffees again. So we'll pull from our coffees endpoint. We'll just call this all equals service dot get all coffees. Sweet. Now we need to do the same thing. We'll probably want to retrieve a coffee by its ID. So fun, by ID, we'll use a path variable to extract that. Oops, I'm going back to Java. Oops. And we'll pull an ID there. And we'll just do a service dot get coffee by ID for the ID. I find that when you switch back and forth, again, Java and Kotlin, the friction is pretty low. The biggest thing I have trouble with is adding the semicolons back in. Go figure. So we're going to do a get mapping here so we can get our operational insights and see what orders are being processed. Fun orders. Once again, here we'll use a path variable for our ID and string. And here we'll just do a service dot get orders for our ID. And that's almost good enough. But with a REST controller, it expects everything to complete, all the values to come back, and then it sends them in a single document. We know because we wrote this code that it's going to be sending back a value every second, like forever, right? So how do we deal with that? Well, the good news is that, that Project Reactor does support things like server sent events and WebSocket and things like that. We also have RSocket support, which is there. It's a little more manual at this point, but with the next release is supposed to be much more integrated. So that's kind of nice. But for now, we'll just stick with server sent events because we're producing a single pulse, right? It's just outgoing, so that works a treat. So I'm going to indicate this produces a media type. And of course, we need to just create an array because we can potentially create multiple media types. But I'm going to create a media type of text event stream value, which indicates that this will produce what? A stream of server sent events. So let's go ahead and restart this now. Actually, that just means that I've got 2 instances of it running here. So let me go ahead and stop this, and we'll do this right. Except I just did the same thing again. Holy cow. Oh, there we go. That's fine. Okay, so we're up and running. Everything seems to be working. Let's go out here and test it just from the command line. So I actually will do this. I use HTTPy again because I like it. I think it's, as they used to call it, curl for humans. And we see that we've got our list here. Let's go ahead and grab one of the IDs. For Simon, we'll grab Azul. And look at that. We'll see what orders we have coming in for Azul coffees. So orders, we'll go back here and indicate to HTTPy we've got a stream coming in, so don't wait for the finish. And we're getting those coming in just fine. So let's see, we've got a couple of minutes left, right? Yeah, just a couple of minutes left. I don't want to run too long, but I want to show you a couple of things. I guess let me ask you this. Would you rather see the way of defining routes functionally, or would you rather see the Java client? Because both have value, right? The other one you can look in the repo. You know what? Let's just do the functional routing, and if we still have like 30 seconds left, I'll do the other one. Why not? So we've got everything working. We'll comment out our REST controller, and we'll do this a little more functionally. If you're coming from a functional background, this will probably look a little more at home. You'll be a little more at home. So I'm going to create a configuration class. We'll call this router config. And again, we will inject our service so we can leverage that. And we're going to define a route. So this will be a bean. And let's see, fun router equals, and we have a router DSL. Let's see, router. There we go. Nope, that's not right. Oops, fun route equals route. Yeah, that actually is right. Okay, go figure. All right, so with our router DSL, we can define our routes that we can, and we can define them in a functional manner. So I'm going to, let's see, I want to create a list of routes here. So we'll do a get, and each get, in our case, we're going to create 3, just like we did with our REST controller. We're going to create a pattern and then a lambda that will supply that. So we've got a get / coffees. And what I'm going to do is just, because it's expecting a router function here. So I know, because I've done this a time or two, that we're going to have to define a function that will take a request, a server request, right? And it will respond with a server response, a mono of type server response, right? Because this is all reactive. So we're going to return an OK, and we will provide the body here, which in this case, we'll just use our service, get all coffees. And we can see that it returns now a mono of server response. So we'll just plug that in. There we go. Okay, so, and actually the list of, I like to do this so I can just see this a little bit more nicely. And we'll do another get. And in this case, it's /coffees /ID. And here we'll just do a by ID. We'll fill that in momentarily. We'll do another get /coffees /ID /orders. And here we'll just do another function called orders. Right. Okay. So in this case, again, we'll just, in interest of time, I'm going to do something I don't like to do. We'll just do a copy paste. We'll rename this to by ID. Sweet. And actually, why is that? There we go. And in this case, we'll do a get coffee by ID. We'll use our request to extract our path variable for ID. And there we have that. And then for our orders, we'll do something similar, orders. In this case, though, we're going to return get orders for coffee by ID, same thing. And then instead of returning just a body, we want to return a body of server sent events. And there are other ways you can do this, but this is my personal favorite. I think it's very clean and elegant. So as long as I didn't typo in there, we should be up and running here shortly. Sweet. Look at that. Okay, so we'll go here and we'll repeat the experiment. Coffees, all that works. We'll grab the Americano. Oops. We'll try again. I'll grab the macchiato up there. Oh, /required. Look at that. That works. And we'll do an orders, and we'll see what we have in terms of orders coming in. See if that's a popular drink. And indeed, it is. So we've got everything working. We've done it a couple of different ways with your typical kind of MVC mechanisms of creating a controller class. We've also done things a little more functionally. I regret that I don't have time to do the client, but I do have all the clients out there and all the services out there in the repo. And we'll wrap up here so you can see where they are. Always helpful, right? Okay, so everything is out under my repo, FSR, full stack reactive. So I have a Kotlin service, a Kotlin client, a Java service, a Java client. Feel free to mix and match those. It just all works, right? And then if you want to know more about the Reactive Streams initiative or Project Reactor in particular, I'm actually really proud of our documentation. So if you want to know more about Project Reactor and debugging and tracing and all the other crazy topics that you will be getting into, it's all out there. And it's actually pretty well documented. So with that, thanks so much for coming, and we'll see you.